All right, so yeah, I'm glad that it seems like most of you are still here. I think we had a completely full class on Monday, and then there's a couple of this week, but it seems like most of you still are here and want to be here, which is good. So I kind of hinted on Friday about how the grading system was going to work, and now I figured I'll dive in just a little bit further and reiterate it, re-explain it. I didn't want to do too much grading on Friday, so I kind of sort of split it up between 2 days so that you sort of knew, but I did it now so you sort of knew how you'd be graded while you're working on Scratch. So on Friday, I introduced this really complex, super complicated system that we're calling the checkmark system. And it's actually really not that complicated. So if you do all of your work well and your program runs and it satisfies all of the minimum requirements, you get a check, which is sort of in the range of a B, a B+, maybe on the lowest tier of an A-. It's actually going to correspond most likely to about a B+. And then, depending on whether you do well above the minimum requirements or you have additional little stylistic flourishes, your code follows a certain style that we'll be harping on more throughout the class. It's well commented, whatever that means. And it might have additional features. You can get additional things such as check pluses and pluses. And likewise, in the opposite direction, check minuses and minuses. And so, this is a little vague right now, and I can see myself having a lot of problems later with trying to argue and negotiate, well, is a check really a B or is it an A-? Because here I kind of have it listed as both. So we're going to make this a little bit more rigorous. There is going to be sort of a point system, and so depending on what grade you get, you're going to get one of the above points. And you can see it ranges from about 4 to 8. With 10 being the plus and 2 being the minus. And the first thing to realize is that this is not a typical grading scale that you might be used to. 6 does not represent 60% because it's 6 out of 10. First of all, the highest that you can really get, and this is going to be an 8, because that's the plus. The plus is extra credits, above and beyond. And so, since 10 is 2 more than 8, it's about 25% extra credit. If you can really somehow manage to nail down a plus. But even so, because 6 is sort of in the middle, that still doesn't represent a middle grade. It's not going to represent a C. And so if you add up all of your points at the end of the semester, a check will probably wind up being about a B+. And so I have sort of calculated a tentative point total list. So everything we do in this class ultimately will be out of 100%. And on the syllabus, I sort of showed you how much each project was going to be worth and how much the exams are going to be worth. And so the exams were 10 and 15%, and then the projects had sort of an escalating percentage. Well, if you take that percentage of whatever your assignment is and multiply it by the number of points, you'll get sort of how many quote-unquote points you'll get for that assignment. And so, since there's a 100% maximum, and I'm having 8, the plus, be the highest total, there's going to be about 800 points total that you can get in this class. And so the scale, tentatively, is going to be as thus. So, all pluses, you're the best that you can pretty much be right now. You're at 800, you're at the max. And I actually should put above 800 will also be an A, because if you get all pluses and maybe a couple pluses, you'll be above 800 points. But a couple other things that might jump out at you. So the check plus was a 7. So if you got all check pluses, you'd be at about 700 points, which is still roughly in the A. If you get all checks, since a check is worth a 6, you'll get in the 600-point range, which right now is a B+. So checks are not bad. Checks are good. And I imagine most of you will get somewhere between a check and a check plus on hopefully almost every project. Kind of the goal of this class and the way that I'm creating and running this class is that the projects are going to be challenging. They're not necessarily going to be difficult. Challenging and difficult are 2 different words. But they will force you to work. And if you work at it, and you get a good program, and you get a check, that is a good grade, and you should be proud of yourself, and you'll be rewarded thusly. I imagine the majority of check minuses and minuses will come from you couldn't complete and implement a specific feature, or the work became a little too much and you just couldn't complete all of it. But doing the bare minimum in this class will be a good thing. And so I'm trying to sort of raise the level of discourse and really give you guys good and interesting things to work on, and when you're done with it, hopefully it'll be something that you can be proud of. So any questions sort of on this? I know it's different. It's not maybe what you're used to, and when you start out in college, there is a lot of rigor usually in how things are graded, and we're trying to sort of reduce that a little bit in this class so that you can be free to not think too much about your grade and really just think, let me get this project running. Let me get it working because I know I'll be rewarded with a good grade if I get it working. And this way we also don't have to have exams and all of that, because the problem with most classes is that if you give homework assignments or programming assignments, which are really easy, then everyone does them, they get 100%, and then you sort of have to have exams to differentiate between people. So I'm sort of raising the difficulty of the problem sets so that we can have more of them and have them be a bigger part of our grade. So any questions on this? Let it sink in for a second. So also one thing to notice is that as you get lower and lower and lower, if you get nothing but a check minus, this is still a C in the class. Or actually, sorry, a check minus will be a C minus, because that'll be at about 4 points for a check minus. No, sorry, check minus is 5 points. So actually that would be the lowest possible C plus that you can get if you get nothing but check minuses. And then likewise a minus, which is below a check minus, is a C minus. And then anything below that will be an E. And I won't be rewarding D's in this class because I don't even think you can really get them. If you're not doing the work and you're getting minuses, I'm going to give you an E. Okay, so the next sort of order of business is that tomorrow starts the discussion section. So if you go to the website now, the discussion sections are sort of posted with the TA that will be in that section. We also have a staff TA page which shows some of the TAs as well as the office hours. So what is required of you at the discussion tomorrow? I would suggest if you have laptops, go ahead and bring them. The main goal of discussion will be sort of a more personal, intimate understanding of the material with the TAs there for you to be able to consult. So you are allowed to basically do whatever you want to do in the discussion section. I will allow you to work in your Scratch project. You can follow the handout. So I didn't post it over the weekend. I got a little behind. I'm going to post it tonight. There will be a handout on sort of installing Sigwin if you have a Windows machine, working out of the terminal, creating your first Java program. You can do this on your own time and work on Scratch in your discussion section. Or if you're already done with your Scratch project, you can work on a handout. If you feel completely comfortable, you don't have to attend the discussion section. They're only there for the people who really want to be there. In addition, I've talked to some people who have conflicts. I would like, if at all possible, for you to go to your discussion section, but if for some reason you can't make it, or you don't like the time that you signed up for, I will allow you to go to another discussion section. If you find a TA who you like more and you think it will help you more, you're welcome to go to that TA session. I don't want to sort of pigeonhole you guys into the rigor of the university policy. We're going to be a little more free-form in this class. And so I want you to be able to seek the help of who you want to help you. So try to go to your main discussion section tomorrow so we can get sort of a feel for everyone being where they need to be. But throughout the semester, you're welcome to jump into other ones. You can stay for multiple discussion sections if you want more than 2 hours of help. That's completely encouraged. So tomorrow, you'll get sort of an introduction from your TAs. You'll get the handout, and you can start to work on whatever it is you want to work on. Additionally, we'll have office hours now. And so those are posted on the staff side. I think today we have someone who has office hours from 2 to 4, maybe Leah. I will have office hours today from 4 to 5, and my office hours in general are going to be Mondays and Wednesdays from 4 to 5 in E404. So that's this building, but the 4th floor. If you walk up the steps and then go directly out and make a right, it's the first door on your left. It's sort of a big, not too big, but it's sort of a conference center, so I can handle multiple students. So I'll be sitting in there Mondays and Wednesdays from 4 to 5. And if we need to create a bigger room, because there are a lot of people coming, we'll take it as we need it. So any questions on the announcements or any other administrative stuff before we actually move on to the meat of the class today? Good. So we started talking on Friday about sort of motioning from Scratch into actual Java syntax. And we saw Scratch on Wednesday with sort of this intuitive graphical interface for writing programs that had puzzle pieces and you can connect them and create sort of a logical flow. And then Java we introduced as this sort of more rigid syntax. And the rigidity is what makes it more powerful. And so there are many more things that you can do in Java versus Scratch. And you can create all these different various puzzle pieces for sort of creating the same kind of program flow, but for doing even more. And so on Friday, we kind of introduced what some of the Scratch pieces were and saw how certain aspects of Java syntax relate to that. So for instance, the say block, the safe puzzle piece, had an analog in this system.out.println hello world. And we create a hello world program on both Wednesday and looked at it again on Friday to sort of show you what that statement actually meant. And it just sort of prints something to the screen. System.out.println is a function, which we'll be talking about a lot more later in the week, which takes a parameter, which is strictly, what do you want it to do? What do you want it to print? You want it to print the phrase, hello world, which is the argument or the parameter to the function. And we also looked at Boolean values, these are mainly used to figure out program flow. So you use these in an if-then statement when you want to say, well, if this value is true, do this, otherwise do something else. And you can have hard numbers in a Boolean expression, like 1 less than 2. You can also have variables. And then there's also additional structures such as ands and ors. I can say, if this is true and this is true, then do it. Or I can say, here are two things. If either one of them is true, then go ahead and do this. If the right mouse button is clicked or the space bar is clicked, do this, do the same thing. So I'm allowing sort of multiple functionality. And Java implements ands with sort of 2 ampersands. And the reason it doesn't use 1 will, I guess, not be as apparent in Java. This is actually sort of a borrowed over from C++, which has a specific keyword or the ampersand has a specific meaning, and so an and in C++ is just 2 ampersands, and in Java they sort of borrow the same thing. And or are 2 vertical bars, and you can find that sort of just above the enter key on your keyboard. If you hit shift and the button just above enter twice, that'll give you an or. So as I said, we use these Boolean statements in if-then statements, and so you might say, if x is less than 5, then do something. Do what's in the curly brackets. The curly brackets sort of demarcating where the body of your expression goes, sort of similar to the white space in the block. And you can put as many things as you want and just sort of cut them off with these curly braces, and it'll do everything inside of that control statement. And you can also have an else. So if it's not true, then do something completely different. Now, you don't have to have an else there. You can have just an if statement and say, well, if this is true, do it. Otherwise, just ignore it, move on, don't worry about it. But then you can also sort of say, well, if it's not true, then do this instead. And you can nest these. You can have multiple ifs inside of other ifs. So I can say, well, if this is true, okay, then do this. But if this is true and I'm now in this sort of part of the program flow, give me another if statement. Well, then if this is true, divert down this path. And you can have almost like a tree where you're picking a lot of different paths that you can sort of go down. So, if you hit the mouse bar, or sorry, the mouse button, the first mouse button, the left mouse button, but the space bar is also pressed. So then you might have inside that, if space bar pressed, underneath, if first mouse button pressed. And you can nest these as such, and we'll see that also later in the week. We've talked about the notion of loops, and so you have this structure where you might want to do something many, many times. And we sort of saw that if you have a command that you want to repeat, it's not really good form to copy and paste it over and over and over again. So you could throw in a simple loop, such as a for statement, and tell it how many times you want it to execute. And I sort of broke down on Friday what this for loop really is. It's 3 different things contained in the parentheses. The first one is the initialization. The second one is the condition. And the third one is something that operates sort of at the end of the for loop. And so what's happening here is that it's taking a variable, I, setting it equal to 0, and then at the end of the for loop, it keeps incrementing it. So it goes to 1 and it goes to 2 every time it reaches the end of the for loop. But it's checking the middle thing to see whether or not it actually runs. And so it's checking, is the value of I less than 10? If so, continue to run the loop. And they keep incrementing so that eventually it will no longer be, the condition will no longer be true, and it'll go ahead and exit the loop. And so we also saw that while loops have the same functionality, except they only have the condition. They don't have the initialization step or the update step. You might do all of that sort of on your own in the middle of the code, where you might say, you might explicitly write at the end of the line, I++. And maybe you have int I equals 0 somewhere else throughout your code. And these are useful for lots of things that we'll see sort of later on. There's another kind of loop, which I don't have on the slides, known as a do-while loop. So if you notice, the while checks the condition at the very beginning of the statement. It says, if this is true, go ahead and run this. The do-while loop, I might show that when we actually get to writing our program out later today. The do-while loop says, okay, do this. Don't bother evaluating the condition, just do it. And at the very end, evaluate whether you should do it again. So if you want something that you definitely want to run once, but you're not entirely sure if you want to run it again, then you can go ahead and use a do while loop. An example of this might be if you want to get input from the user. You might say, well, I definitely want to get input at least once, but if they don't give me the right input, maybe I want to repeat it. So you can have some kind of condition which says, is the input that they gave me valid? And if it is, then whatever is in the while statement at the very bottom, so the do is always at the top and the while is at the bottom, you might evaluate that to false if you liked what they gave you, and then you'll exit the loop and continue. If you don't like what they gave you, you might have the while statement evaluate to true, which will bring it back to the top and force them to give you input again. So I might either show that at the end of class today, or if we don't get to it today, I'll do it on Wednesday's class. So these are sort of the main constructs of Java. You've got variables, you've got loops, you've got conditions, which are your if-then statements, you've got general statements, and it's these simple constructs which you can really sort of build up to create big and complex and interesting programs. And so we sort of saw the first program really twice. I showed it on Wednesday and again on Friday, this simple hello world program. And over the next couple of days, we're going to break it down more and more and more. I'm going to sort of introduce additional pieces so that eventually you're going to understand exactly what's going on in this program. But again, suffice to say that we're not going to talk about what the public class means just yet. That will be when we get to objects. The public static void main is a function, and we're going to get to functions on Wednesday, where we'll talk more about functions and how similar they are to the functions that we saw in Scratch. But suffice to say that main is a function which exists in this hello object that I've created, and I can access it whenever I run Java hello. That simple command, Java hello, the reason it's Java hello and not Java something else is because I've named it hello in the class. And then the main is sort of implicit. Whenever I run Java some kind of class, it will always go to that class and then figure out where's the main statement. And so it's really looking for that green name, main. And then string args is arguments. So again, functions can take arguments if you want to give it explicit behavior. The string args there is just saying that don't worry about now how it's supplied, but somehow I'm going to be able to receive command line arguments for how I want my program to run. And I'll sort of show that probably also on Wednesday. The type for that is a string array. And so we'll get to arrays, which much later in the class. But suffice to say, an array is sort of a large container of many different things. So this is saying that it's expecting a container of many different strings. And so I can sort of give my program lots and lots of additional options if I want to tell it what to do. But this is still a little bit above where we are. So we're not using any of the command line options. We're just doing a simple print statement. And so I use the same functions that I showed from the Scratch say block, which is system.out.println, and I put in hello world. So now we're going to dive a little bit deeper into variables. And so I showed off variables a little bit on Friday when I started playing around with the hello world program a little bit. So I showed that I can give the system.out.println a simple string, and I can give it the hello world string, or I could define a variable. And if I defined a variable, I could stick a string inside that variable, and then I could just pass around the variable as if it was the string itself. And so why might we want to do this? Why might we want to have variables to store our information as opposed to just passing around the string to begin with? And the main idea behind this is that that's how our programs really contain and pass around information. That's how we allow interactivity with the user. We have variables which we're setting the sort of different features, and then the computer knows how to reason about those variables. If we didn't use variables, then and we just hard-coded all the information, the computer would do the same thing every single time, and that would be a pretty boring computer, or a computer program. So allowing variables sort of allows it to hold information, but more importantly, allows us to have ways to change that information and change sort of the state of the program. You could think of the state of the program to really be the value of all of its variables. So you can define sort of the state of a program by what all of its variables are and then what the values of those variables are. You could think of yourself almost as being composed of variables which have specific values. You have a variable for eye color, which is initialized to a certain value based on who you are. A variable for whether or not you have facial hair or not, whether you have long hair or short hair. You could think of yourself sort of as having all of these properties which are defined by variables. And so a program has sort of a similar functionality. It's composed of generally a lot of variables, which all have their values, which give that program its character, so to speak. So a variable really can be condensed down into three things. A variable is its type, a variable is its name, and a variable is its value. So the name is pretty explicit. It's just what do we want to call that variable. The value, same thing. It's the information associated with that variable, what's stored sort of in that variable. You can think of a variable like a bucket. It's a big bucket which holds some kind of data. And so the value is just what goes inside the bucket. Now the type is something that we're not as familiar with. There aren't types in mathematical variables, but we have types in Java. And the reason that we have types is that it makes things a little bit more efficient. The computer needs to know what kind of data it has. So you need to tell it in advance, here is a number, here is a string. So it knows sort of the various operations that it can do. For instance, on Friday, I showed that you can concatenate two strings just by using a plus sign in between. So if I have a string plus a string, it knows to stick them both together. But how does it know if I give it the number 5 and the number 10, and I put a plus sign in between to add those together and give me back 15? It knows that because it knows what types those variables are. It knows what type the number 5 is. Or if I store it in a variable, it knows that that variable contains a number versus something else. So by giving these variables type information, you can sort of increase the utility of them. You can, rather than having a different operation for concatenating strings versus adding numbers together, since we have the type information, we can have sort of one operation and allow the computer to sort of infer, based on what the type is, what the operation should be. So how do you create a variable? Well, it starts with a declaration. And it's simple. You just put the type and the name, and then a semicolon. And if you remember, a semicolon in Java tells you where the end of the line is. And so you start out to get a variable, you just say, for instance, int I. What is this saying? It's saying, give me a variable called I, and make it of type int. Int is a specific type in Java, and I'm going to talk about all the various types that Java has in a couple of slides. But suffice to say, the easiest way, or the most basic way of declaring a variable is saying the type and the name. And so why do you have to declare the variable? What you're really doing is you're telling the computer, take some space in memory and allocate space for this variable. So in this case, however much space is allowed by an int variable, allocate that much space and call it I. Now every time I refer to I, I'm going to refer to this space in memory. So in addition to declaring a variable, when you create a variable, again, you can think of a variable as almost a bucket. So what you're really doing when you declare a variable is you're instantiating that bucket. You're creating this big red bucket I, which is of type int, and then storing it somewhere in memory. You also have initialization, or also equivalently assignment. So remember, assignment uses the equal sign in Java. So in the pseudocode, we use sort of the left arrow to assign something into something else. In Java, it's simply equals. So this is now saying, I already have an int I that I've gotten from somewhere else. I've declared it somewhere else in my program. Now actually set it to something. And so if it's the first time you're setting it to something, it's called initialization. If it's maybe further on in your program and you're just changing whatever value it currently has to a new value, we call that assignment. I'm not going to be too nitpicky on the difference between these terms, just if I do use these terms, that's what I mean. Initialization is the first time, assignment is pretty much any time after that. And so that's pretty much equivalent to taking your bucket of your variable I and putting something inside it. So in this case, it might be the value 0. I would take 0 and then put it inside the bucket and say, now I have this variable I, which is holding a certain value which I can access. And every time I access, by using its name, I get back what's inside the bucket, which in this case is 0. And so an int can specifically store one type of data, integers. So integers are all positive and negative numbers and 0, but not fractions. We have a different type for storing fractions, which I'll show you in a second. So you can also do sort of a declaration plus an initialization. So I've been using this sort of shorthand throughout the course so far, where I can declare something and then later on set it to something, or I can sort of do both at once, where I say int I is equal to 0. So now I've both declared the variable, I've said give me this bucket, and I'm telling it what to put inside the bucket. So int I is equal to 0. So, as I said, the int is only one type in Java. We also have additional types. For example, if you want to represent a decimal number. So you cannot represent a decimal number in using an int type. And so here's the reason why. Remember how we store information in a computer. So information at its core is still bits. An int in particular is 32 bits. So what you can really think of it as is a string of 32 zeros or ones. And the computer knows how to interpret that string of zeros and ones and convert that into an integer number. There are additional data types that might have the same string of ones, or zeros and ones, but because they're a different data type, Java sort of knows how to interpret that into a different number. So for example, if you have a type which is known as double, and the reason it's called a double is because it's twice the size of an int is 32 bits, a double is 64 bits. It might have the same string of zeros and ones, but because it's of type double, that string of zeros and ones gets converted slightly differently into a decimal number as opposed to an integer. And at some point later on in the course, I might talk about how to explicitly convert, say, a binary string of zeros and ones into either converting it into an integer is easy. So we saw on the first day how to count in binary. And so an int is pretty simple. You take the binary representation of an integer number and convert that into the int. How to convert a decimal number into binary is a little bit more complex, and we might get to it later. We'll see if I think that it's useful or not. But the main idea is that this is why we have data types. Because at its core, this information is still just zeros and ones, and we need to know how to sort of interpret it as the data that we want. We have also additional data types for storing characters, for storing strings, etc. So the double, as I alluded to, is sort of twice the size of the int. It's sort of a bucket that's twice as big. And whereas the int bucket, you'd only put integers in, the double bucket, you can put decimal numbers in. And so obviously there is a much wider range of decimal numbers compared to integers, an infinite number, but we only get twice the precision. But this actually lets us, the way that doubles are sort of encoded in binary, there's a large amount of numbers that you could generate. So pretty much any decimal number that you want, you can store in Java, with a few exceptions. And in next week's class, I'll show some examples where you might actually lose some precision because there is actually a finite amount of sort of decimal point numbers that Java can store. And if you have a decimal that's a little bit too long, Java might wind up cutting off the edge of that program. And it's actually led to, in real applications, some interesting and at times catastrophic results. So to sort of understand what's going on at the variable level, I have to sort of go back and talk in terms of bytes. And so whenever we talk about memory in your computer, I'll really be referring to that as a byte. And so there are bits and there are bytes. They are connected by the fact that a byte is really just 8 bits. So it's sort of one step up. In the same way that 1 foot is equal to 12 inches, 1 byte is equal to 8 bits. And the reason this is important is because in memory, the smallest sort of indivisible section of memory is a byte. You cannot go in and access individual bits in memory. You can only access an entire byte. And so this becomes important. So as I said, an int is 32 bits. So it takes up 4 bytes in memory. And so you can imagine sort of when you're calling these variables that what you're really doing is accessing them in memory. What a variable stores, so it's kind of a misconception that the variable that you're reasoning about in your computer program has the actual information inside of it. It really doesn't. What it really has is a memory address. And so when I say int I equals 0, what I'm actually saying is give me the variable I itself is referencing an address in memory. That address in memory can actually be used to sort of redirect me to the actual location in memory where that int bucket is being stored. And so if I take 0, what I'm actually sort of doing is going from my variable I to the memory address, going from the memory address and using that as sort of an address book to tell me where to actually go in memory, and that's not where I can access the actual sort of information. And so this will become really apparent when we're dealing with objects later on in the course, but it's good to sort of start to think about variables as holding memory addresses and not really the information. They're sort of holding pointers to specific locations in memory. And so, for example, in this slide, the variable A is pointing to the storage address 0002. This is sort of an address in memory, which you might see on the right side. So you can sort of imagine memory itself as just being a long section of bytes that are all sort of numbered in a linear fashion. So when you say this is in memory location 1008, the computer knows where to go in that big long list of bytes to access the actual information that you need. So this is actually what's going on sort of inside under the hood of your Java program. And so there are many different types in Java, but most of these you will never use. So even though I'm introducing them all here for completeness, there's actually a small list that will become much more familiar to us. These are the ones that I've sort of bolded here. So an int you will mainly use when you want to get integer numbers. There is also a byte and a short. So as I said, an int is 32 bits. A short is slightly smaller, it's 16 bits, and a byte is even smaller still. There's no reason in this course that we'll probably need to use bytes and shorts. The reason that they really exist is if I know for a fact that my integer number is within a much smaller range, then I can use a lot less memory. And this is really more important for things like mobile applications or things that either speed is a really important factor or your size is a really important factor. Back in the day, this is even before my day, you would have a severe constraint on the amount of memory that you had. You know, right now we have 4 gigs of memory in most laptops. Back in the day, you might have only had a single kilobyte. And so you had 1,024 bytes, and you could not exceed that. And so you had to be much more efficient with how you work things. But we'll mainly be using ints if we want, in this class, when we want to deal with integer numbers. If somehow you want to count past the highest that an integer can go, and so since an integer is 32 bits, what's approximately the highest number that you can represent in 32 bits? Does anybody know? Maybe not exactly, but roughly. It's roughly 2 billion. So if you want to represent an integer that is more than 2 billion, then you can use a long, which is also designed to hold integers, but we shouldn't have to worry about that too much in this class. So we'll mainly just be using ints for integer numbers. We also have, as I said, the double, which is defined as it is because it's twice as big as the int, which is sort of your main the main type that you'll be using in Java. So whereas a long is sort of a big int, a float is sort of a shorter double. So it's a 32-bit number which can represent decimal places. Again, there should be no reason that you'd want to use something smaller than a double because we don't have the same kind of memory restrictions in this class. But for completeness, if you're reading any kind of documentation or any kind of tutorial that's outside this class that might use these types, I want you to at least be familiar with them. But the main two are int and double, depending on whether you want an integer or you want an actual decimal place or decimal point number. The final two are Boolean, which is really 1 bit, but its size in Java is kind of fuzzy. It's not really represented in the typical way, and so don't worry too much about it, but Boolean values are mainly true or false. And so whereas we saw Boolean values came about as a result of certain operations like is x less than 5, you can also actually store that in a variable. I can say Boolean something equals x less than 5, and that Boolean value will evaluate to either true or false, and I can use that sort of elsewhere in my program. Maybe in one of my conditions if I want to decide whether or not a loop is going to run. So I can sort of store the phrase, the statement, directly in the loop, or I can save it in a variable type Boolean and then use it elsewhere. And then finally, char, either char or char. I generally say character because char because it's short for character. I know a lot of people who say char just because that's how it appears. This is mainly used for evaluating and representing letters, punctuation, symbols, using a 16-bit ASCII system. So we saw ASCII in the first part of the course on last Monday, and we saw sort of how numbers can be represented into letters and symbols and such. And the character type is one way of doing that. So are there any questions on types and variables and things of that sort? Yes. Sorry, it was 16 bits. And these slides should already be posted to the website. Yeah, so if you want a quick chance to write this down again. So the int was 32 bits, the long is sort of a big int, and then the double was 64, the float is sort of a shorter double. Boolean, don't worry about it, and then the character is going to be 16 bits. So again, these are all just strings of zeros and ones that the computer sort of knows how to turn into its specific type. So that's sort of getting to a level that I don't want to get to yet in the course, but for the sake of completeness, the int is going to be a signed integer, so that's how you can represent negative numbers. Whether it's signed or unsigned is sort of how it represents the binary string. So you might see a phrase called 2's complement if you're looking at binary conversion, and this is sort of a way to have an additional 1 in there, which sort of tells you whether the number is positive or negative. This is at a level that I don't want to do too much. I mean, I could spend an entire week talking about variables and types and how they're stored in memory. You guys will get bored really quickly. You'll fall asleep. So instead, I want to sort of cover this briefly and let you explore it more. I think so much of computing is about exploring and not worrying too much about how things are represented. But if you really are curious, we can talk about it more if you either come to office hours or come see me after class. Any other questions before we start sort of diving in? Okay, so I've got my Sublime up. I've got my shell up, and I will give you a second if you want to start to get ready. But this is sort of how I'll handle a lot of the lectures, I think. I'll probably have a few, maybe the first half of the class will be roughly slides and introducing the concept, but I think so much of this course should be about experimenting, should be about exploring, and so I'll be showing off a lot of the concepts sort of in real time. So let's start to do something. So I'll start off with my basic shell that I was using for the hello world statement. In fact, actually, I'll call this something else now. I'll call this calc, because we're going to be doing some mathematical operations with it. So I have my class. I have my long string of words which tell you that I have a function. Let me go ahead and save this so I get my nice little syntax highlighting. So actually, I don't yet have a code folder. So remember how to make a new folder using the shell syntax. So you can sort of see the previous command just to show you again how you navigate a command structure or a file structure in the shell. You use cd. And so this is showing you that I use cd to sort of go to my lecture 3 folder where I'll be working. But since I don't yet have a code folder, I'm going to type mkdir for make directory and then just code. And then that should create a new code directory which just popped up. And this is where I now want to save. And I'm going to call calc.java. Okay, now I get my syntax highlighting. So let's do something simple to start. Let's do what we did before and print something to the screen using system.out.println. So we've been working with hello world, and let's say something like your number is 5. So basically the same as hello world. The only thing is now I've just printed a different string. And so if I go to Java C, because remember I have to compile all of my code. I have to take the form that it's in right now, which is actual source code, and compile it into bytecode, which can be read by Java. So I'm now going to I'm going to run the compiler on whatever this class name is right here, which should always be the same as the file name. So in this case, the class is called calc. I've saved it as calc.java, and so I'm going to run calc.java. File not found. Why would my file not be found? Well, because I created a new code directory, but I didn't actually go into that code directory. So I have to go type cd code so that I actually jump inside of it. Now if I type javac calc.java, and actually before I do that, let me type ls so I can see the actual contents of my directory, and there it is. So javac, not hello anymore, calc.java, I have an error. Why do I have an error? Well, let's see. A class expected. So Can anyone tell what my error is? It's not the void. It's up here. Just if you've seen Hello World over and over and over again, you might have memorized some of the order of the keywords. Yeah. I put static instead of class because I started to type my my main method a little too soon. So this should be class. And so you can sort of see the power of the compiler that a lot of times it will be able to spit errors out at you and say, you didn't really write this program correctly, here's where you went wrong, and here's where you should try to do something. And so it's basically telling me it's expecting either a public class, a public interface, or a public enum. And within about a month, all three of these terms will be familiar with you. So now it should run perfectly. And if I type Java calc, I see my simple phrase of your number is 5. And this is really remedial, but we can go ahead and create a variable. So now I'm going to start storing my numbers in variables instead of just outputting a string as is, because this program, as it is right now, only really has one flow. It can only do one thing. It can print a single phrase. Now I want to sort of give it additional functionality. Well, right now it's going to have the same functionality, but it's going to be written a little bit differently. So I'm going to declare a variable. I'm going to give it a type. So this type is going to be int. And now you can see one of the nice things about syntax highlighting is that it recognizes the various types in Java, and it codes it with a blue keyword. And I realized I forgot I have to sort of stretch this over so that you guys can see. Yes. So an int, which it immediately recognizes as blue, and I can call this int whatever I want. I'm going to call it num, for number. Now what I could do is I could declare it and then initialize it somewhere else and call it, say, 5. Or I can sort of combine everything into a single statement, which I will do. So I'm going to say int num equals 5. And I have a semicolon to sort of show me that I'm at the end of the line. So there are a couple ways that I could do this to actually print the number. I could create a type string and call it maybe phrase. And then say your number is, with a space, and then use my concatenation, which is a plus sign. So if I have two strings, I can concatenate them using a plus sign. Can I do this? Your number is plus num. You would think that I can't. And everything I've told you up until now is that I can't. Well, let's see whether or not I can. So it compiled fine. It didn't actually notice that there was a compiler error. And so this is confusing, because I have one thing that is of type int. I have another thing that's of type string. I'm combining the two of these together, where one thing is a string and one thing is an int. But this is sort of what we call type inference. So there could be a little bit of fuzziness when you combine these two things, and Java is able to sort of infer what it is that you mean. Is it more likely that phrase, well, so it knows that phrase should be a string because I've defined it as a string. So since it knows the final product should be a string, it's able to do sort of a conversion. It's able to convert this int num into a string. But that's not really as important right now, the specifics of it. But suffice to say, I could take phrase and actually put it in there, or if I want, I can take this entire thing and bypass saving it as a variable and stick it right in as the parameter, and this would run just as fine. And so you can go ahead and declare everything in variables as you want, or you can sort of do things sort of in the parameter space in which you are passing them. This is stylistic, and it won't really matter. Depending on sort of the case, you can decide for yourself which one you think is more likely. Maybe if I'm building a complex phrase that has lots of variables, I'll store it as an additional variable, or I can just pass everything straight through to the command line. But we are not quite going to get to strings, but I just wanted to sort of show you that I can output a string and it sort of easily converts it to a num. But this doesn't really do anything interesting. So let's do a little bit of math. Let's create a second num. I'll call it num2. And actually, I'm going to, because this can get really, really repetitive pretty quickly if I'm just naming all of them num, I'm going to call this x and then call my other one y. Let's make this a little bigger so we can see it. So I'll call x 5 and let's call y, I don't know, 10. So what I can do is I can output both of them. So I'll say your first number, let's say, is x, and then I'll copy that, and I'll add an additional one for y. So one thing that you'll notice now that I'm using two print statements is that this print ln for print line will print something on a line all by itself and then immediately send you to the next line. So by putting both of these print statements one after another, what I'm actually going to do is get both of these sort of on different lines. And so if I quickly compile this and run it, I get my first number, and actually I should have put that as second number. First number is 5, your second number is 10. And again, if all you can do is print things in Java, then this really isn't interesting at all. Question? Sorry, it require an inline? So Java doesn't necessarily. So it depends on what you're using. So actually this will be a good chance to introduce a slightly different function. So print ln will print the line. Let's see what happens if I took away the ln and I included just a print statement, which does not go ahead and create a new line for you. So I compile it, I run it, and I get everything that's sort of jumbled together. So there are ways to sort of invoke just print and sort of create the new line on your own, and we'll get to that in a second when I talk about certain special characters that you can use in strings. But the main idea is that you want to, for the most part, use ln because it'll give you everything on a nice little line by itself. So C, for instance, doesn't have an ln, so you have to sort of control when you want to create a new line on your own. But Java is nice. And so we can go one step further and do a little bit of math by typing system.println. But now I'm going to say your sum is, and I can actually do some actual computation inside of Java. I can say x plus y. So I've included now two variables. I'm adding them together, and I have parentheses. So notice that I have parentheses so that if I had something such as this would be no good. Well, exactly. So I was going to ask, what will this do? It'll actually display them. So what it's going to do is it's going to look at, okay, I see three things that want to be added together. One of them is a string, so it's probably likely that the other two are also going to be strings, and it's just going to say your sum is 510. So by putting parentheses around these, it's going to do sort of an order of operations just like in math, where it's going to add those two numbers first, and since it sees that they're both ints, it's going to add them together, and then it'll be able to display the results. And so if I compile this, oops, and this is something that will happen again and again to even advanced programmers. You forget the stupid semicolon. So you always have to know that. Oh, and I forgot the parentheses. I'm all over the place. Okay, that should run fine. And so then I can print it out, and I'll say, your first number is 5, your second number is 10, but your sum is 15. And so this is one of the powerful things in programming, is that you can do math with it. And given some of the statements that I've already sort of given you, you can start to actually create a calculator. And usually one of the first projects in Java is a calculator. It's kind of simple, kind of redundant. We're not going to do something as simple as a calculator. But we'll start to build up maybe some of the different steps that you can use for a calculator. And so, I want to leave you, actually, since most of you are starting to pack up and we are at the end of class, now that we are officially in Java, with a video that I'd be remiss if I did not show it to you. Some of these things that are mentioned in this video won't make as much sense to you. Some of them might. But by the end of class, you'll be all chuckles. And so I'll see some of you in discussions tomorrow. I might be walking around during the discussion, just to see how things are going, but otherwise,
in the cubicles,
after this,
representing for my Java homies! In by 9, out when the deadlines are met. Shake it! We're going hard in these cubicles. Styles nerd chic, I'm a programming freak. We're going hard in these cubicles. Only 2 hours till your deadline, don't sweat my technique. Sipping morning coffee with that Java swirl. Born to code, my first words were hello world. Since 95, been Java coding staying proud. Started on dropping this, now we take it to the cloud. On my desktop, Java's what's bobbing and weaving. I got another winning app before I get to I. Blazing code like a forest fire climb. climbing a tree. Set ends like IEEE. Boot it on up, I use the force like Luke. Got so much love from my homeboy Duke.
Duke, by the way, is the mascot of Java.
On my desk when you need a crash. Written once and my script runs anywhere. Your freight's bugging, me mugging in my Aeron chair. All the best lines of code, you know I wrote them. I'll run you out of town on your dial-up modem. Cause we code hard in these cubicles. Me and my crew code heights, we hardcore. We code hard in these cubicles. It's been more than 10 years since I've seen it for a board. Inheriting a project can make me go berserk. Ain't got 4 hours to transfer their framework. The cleaners kill the lights. Man, that ain't nice. Gonna knock this program out like Kimbo Slice. I program all night, just like a champ. Look alive under this IKEA lamp. I code harder in the midnight hour. E7 on the vending machine fuels my power. PS3 the smartphones, our code use never ends. Java's there when I meet you in words with friends. My developing skills are so fresh. Please detect, you better step your game up on that C++. We know better than to use .NET. Even Dan Brown can't code as hard as me. Java's getting bigger, that's a promise, not a threat. Let me code it on your brain so you never forget. We code hard in these cubicles. It's the core component of what we implement. We code hard in these cubicles. Straight to your Java runtime environment. We code hard in these cubicles. Keep the syntax light and the algorithm tight. We code hard in these cubicles. Gotta use Java if it's gonna run right. We code hard in these cubicles. Java keeps adapting, you know it's built to last. We code hard in these cubicles. Robust and secure, so our swag's on blast. Code hard.
So this is what happens when you really, really, really love Java. I will see you guys on Wednesday, and some of you tomorrow.
Before you log off,
Oh.